Alright, in order to graph quadratics, there's really three basic steps we have to do. The first one, we have to find the x-intercepts. The second step is we have to find the x of the vertex. And the last one is we have to find the y of the vertex. Now remember, when we're talking about a quadratic, obviously we're talking about either a graph that looks like this or a graph that looks like this. We're going to be opening downward or we're opening upward. Now the vertex is going to be this point here, so where it goes from increasing to decreasing, or this point here where it goes from decreasing to increasing. The other thing I want you to realize about these is when it's facing down, this is a maximum value or the peak of that hill or mountaintop. This, when it's facing up, is a minimum value. Or the valley of kind of that drop or whatever you want to call it. So we're looking at a minimum or a maximum value depending on what kind of function we're looking at. The other thing, remember, when our a value is positive, our quadratic will be facing upwards. When our a value is negative, it's going to be facing downwards. So just a couple other things that you can remember while we're working through this. Now if we look at our example here, there's a couple of things that we can see and a couple of things we should know before we really even get into graphing it. The first thing, we've got our quadratic, which means I've got two different answers here, two different x-intercepts. So when I'm looking at it on my graph, I'm going to have two different x-intercepts. The value of those I don't know yet, and I know that this a value is a positive 1. Since it's a positive value, it's going to be facing upwards. So I've got an idea of what that looks like. What I need to find now is I've got to find what these two values actually are, and then the final thing is, where is this vertex? Once I find those three things, I can graph this with no problem. So let's get started. First thing is, it says to find x-intercepts. We can do that either by factoring with the big X method, or if we can't use the big X method, we could use the quadratic equation. Fortunately for us, in this example, we'll be able to use the big X method. So I put my negative 12 up here. I got my negative 1 down here. I'm looking for two numbers that multiply together to be a negative 12, and then combine to be a negative 1. If I think about negative 12, I can use 4 and 3. Because 4 and 3 are going to multiply to be 12. If I make my 4 a negative, negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. So we're good to go there. Let's write it as our binomial. I've got x minus 4, and I have x plus 3. Set them both equal to 0. Now, so we factored it. We've got it broken down. Now we just one more step, and we'll be able to find those x-intercepts. So break it into two problems here. X minus 4 equals 0. X plus 3 equals 0. If we look here, let's give us a little bit more room. Here we go. If I solve here, if I add 4 to both sides, I'm going to see that one of my x-intercepts is at positive 4. The other one I'll find over here, if I subtract 3, is at negative 3. So when I look over at my graph here, I've got 1, 2, 3, 4. One x-intercept at positive 4. The other x-intercept is at negative 3. So cool, I've got two of the 3 points that I'm looking for. And we got that by factoring and solving. So if I get rid of my factoring and solving, and now let's find the vertex. Now to find the x position of the vertex, we use a formula, and it's parts of it can be similar to the quadratic formula. But all it is negative b divided by 2a. So in this case, my a value, which is in front of x squared, is a 1. My b value is a negative 1. So if I plug those in, I'm going to have negative 1 for b and positive 1 plug it in. Positive 1 for A. So a negative times a negative is a positive. I have a 1 here. 2 times 1 is 1/2. So my x vertex, so x is 1/2, and I'll put my x-intercepts up here too. I had x equals 4 and x equals -3 were my two x-intercepts. Alright, so I've got my x part. I've got 1/2. Now the last thing I have to do is find the y part of the vertex. So if I get rid of my x part of the vertex, and now this is probably the simplest part, to find the y, all you do is plug your 1/2 into the actual function. So I'm going to have 1/2 squared minus 1/2 minus 12. If I do that, I should have 1/4 minus 1/2 minus 12. It's going to give us some sort of negative number. Let's find a common denominator here. So I'll have 1/4 minus 2/4 minus 48/4. 1 minus 2 gives me a -1, minus 48 gives me a -49/4, which is a little bit less. We'll say it's -12 1/4. If we look on here, 1, 2, 3, 4, 5, 6, 7. So we'll be at x is 1/2, y is -12 1/4. Kind of hard to see, it goes off this graph a little bit, but it's going to be right around there. I know because this a value is a positive number, it's going to be facing upward. So really now all I got to do is connect these in the shape of a parabola, and life is good. So the three major things we have to do when we are graphing a quadratic is we've got to find my x-intercepts, which we found here. Then we've got to use the vertex formula and find my x value, which was the x of this point. And then I plug it back into the function to find my y value, which would be the second half of this point. And then a little food for thought. Remember, if a is positive, it faces up. If a is negative, it faces down.